Good day, everyone. My name is Gerald Daniel, and on behalf of the University of Utrecht, I would like to present our ongoing research project titled Environmental Assessment or Impact Assessment of Bio-based Feedstocks as Fossil-based Bitumen Alternative for the Road Construction Industry in the Netherlands as the case study. And our university is part of the consortium called Circle Road, which essentially consists of construction companies, road owners, and also knowledge party such as TU Delft, us, and Wageningen. And yeah, as an introduction, I would like to share about the objectives of this research project and why is this important. So according to the Dutch data in 2016, back in 2016, the total carbon emission is about 550 kilotons. 40% of it comes from the raw material acquisition, from stone mining, from bitumen production, and so on. So pretty huge. And in relation to the target from the Minister of Infrastructure to reach climate neutrality, and having circularity in the infrastructure project in 2030, 5 years from now. This is quite an ambitious project or goal. So one solution that is currently trying to be applied is to find an eco-friendly paving material. One of them is actually bio-based feedstock or biomass-based feedstock, such as vegetable oils and so on. So the research objective here are comparison of environmental impacts between different types of possible biobinary materials, and also trying to apply it one step further to try to find an hotspots from applying different bituminous mixtures containing various bio-based materials up to the end of lifetime of the structure. So there are several feedstock considered in this project from the byproduct of craft paper industry called tall oil and plant-based oils, vegetable oils, and waste-based feedstocks such as waste plastic oil and so on, and natural rubber and natural bitumen to substitute 30% of virgin bitumen. One disclaimer is that the inventory that I have for these feedstocks or these materials are purely based on secondary data from the literature on the internet, and also current databases available. So pretty much secondary data and not primary yet. And in order to compare or to present this to public, we would like to convert all these impact categories as, let's say, climate change or global warming potential, and there are other impact categories as well, acidification, toxicity, and so we would like to convert all these values according to the monetary values, and we call it environmental cost indicator, ECI, or MKI score, milieukosten indicator in Dutch. Essentially, this is a weighting factor translating those impact categories result to monetary value, and it is based on damage cost calculation, which is related to the willingness to pay to essentially avoid the damage, according to the report of CE Delft in 2020, taking into account the income level of the Dutch household and elasticity in terms of the cost for the Dutch context again. And why is this very important? Because MKI or ECI is a vital component in Dutch project tenders, construction tenders, that it is basically called economically most beneficial tender or MV in Dutch. So having lower MKI score for your materials or your projects are actually very desirable. So in relation to that, because I kept mentioning about biomass or bio-based feedstocks, of course we have to take into account the amount of carbon stored in this biomass during its life cycle. As we know, it takes carbon from the atmosphere, stores it in order for the photosynthesis process and so on. And in order to be considered as permanent storage, we consider 100 years as the minimum lifetime. But is it really the case, especially for the road construction sector? So, having that perspective, we are trying to apply one allocation method according to the road's lifetime. Well, this is one approach that is currently discussed in the LCA community. So, basically, applying this equation, taking into account the road's lifetime and taking into account the losses during the lifetime, like from the use phase, from the end of life because of the recycling, and so all these values are assumed based on the PCR code or the product category rule code in the Netherlands in 2025. So these are all very rough assumptions. Is it really the case? It is an ongoing process still, let's call it like that. But having two or three different scenarios, as you can see what the impacts are, This is basically the accumulation of all 18, 19 impact categories according to the Eurocode 15804. And as we can see, you have the yellow bar, basically the rest of the impact categories, but you also have biogenic carbon here on the with the red bars, and we have the blue bars, climate change, fossil, and so on. And as you can see, there are three different scenarios here. The first one is assuming 100% or fully permanent storage of biogenic carbons. Here, as you can see, the total amount is indicated by the gray font. And as you can see, applying it for 1 ton of feedstock, as you can see in fossil-based bitumen, it costs you, or the MKE score is about 80 euros per ton of fossil-based bitumen. And fully assumed all this carbon storage will give you minus 340 euros per ton of bio-based binder. And the second product is around almost minus 100 euros per ton. So pretty substantial, right? But if we try to apply the allocation factor method, as you can see, the effect is quite substantial. As you can see here, the reduction of MKE score is almost 100% for this, and even almost 200% of this bio-based binders. So the effect is pretty vital, actually, this scenario. And the third scenario is fully eradicating the effect of biogenic carbon storage, essentially taking into account only the values above the x-axis, and as you can see, the effect is even higher. So the conclusions are, of course, alternative binders, bio-based feedstocks, and so on can make an important contribution to the reduction of greenhouse gases or global warming potential and other aims as well. But our MKE final score or ECI final score is actually dependent on the fate or the allocation factor of the biogenic carbon storage, taking into account all this lifetime and so and the losses and everything. So accurate measurement or accurate values are actually very important in our research based on empirical evidence, and also primary data is actually needed for accurate analysis and also to account for the losses, especially for the biogenic carbon calculation. That's why we call it an ongoing project still. So that's all of our presentation. If you have more questions, do not hesitate to contact us through email, either through this email, my email, or the email of my supervisor. Feel free to access this QR code to see more of my profile, my LinkedIn, and so. Thank you very much and have a nice day.